Hi everyone! In this lesson, we're going to look at the relationships we can see in data sets and the vocabulary that we use to express these relationships, or trends. First we have positive correlation. We say two things are positively correlated if, when you increase one, the other increases as well. For example, in graph 2 we can see that the items on the x and y axis are positively correlated, because as we go up the x-axis, we find that the y values of the points are increasing. Our second term is negative correlation. As you might expect, this is the exact opposite. As we go up the x-axis, as we see in graph 3, the y values of the points decrease, which means as we increase the value of the object on the x-axis, we find that the value of the corresponding object on the y-axis decreases. So this shows a negative correlation in graph 3. Our last term is no correlation. We see this in graph 1. There is no overall upwards or downwards trend to any of the points. They're just kind of arranged in a mess around the graph. A good tool we can use to show these trends is the line of best fit. It's very important. Line of best fit. We draw a line of best fit through the bulk of the points so that it shows the trend of the direction. So for graph 2, the line of best fit would look something like this. In graph 3, it would look something like this. In graph 1, we can't draw a line of best fit because there is no overall trend. Now, let's look at some examples. Can we think of two things that might be positively correlated? Perhaps age and height, at least until we stop growing around 20 or 22, right? So if we put age on the x-axis here and height on the y-axis, and we graphed the ages and heights of a group of people, we would expect to see something that looked like this, showing a positive correlation. Now, what might show a negative correlation? Perhaps, let's see, what goes down when something else goes up? Maybe the number of miles you drive in a car versus the amount of gallons of gas left in a tank. If we put number of miles on the x-axis, and gas left on the y-axis, we would expect something like this, where the amount of gallons decrease as we drive more, showing a negative correlation. Remember, your line of best fit doesn't have to connect the dots, it just has to show the trend that the dots are moving in. Now, what shows no correlation? Any two things which are completely unrelated to each other. For example, let's take SAT score and shoe size. As long as we control for age, say these are all a number of 18-year-olds, the shoe size should have no impact on your SAT score, and vice versa. So we would expect to see something like this if we graphed this information for a group of 18-year-olds. Zero correlation. So there you go. Positive, negative, and zero correlation. And your line of best fit helps you find them.